Hi Foundation students. Today we're going to talk about catapults and how they work. Here I have a catapult that I created. To create this catapult, you will need 7 popsicle sticks, also known as tongue depressors, 2 more popsicle sticks, and a spoon. Very integral to this experiment are these rubber bands. They're very important because they create tension, and you can see them on display here. You will also need some projectile. You could use, I'm using a peanut here. You could use popcorn, pom-poms, ping pongs, anything that you can launch that would be safe to launch should it hit someone. In addition, you could use a spoon, as I have here, or a cap. I prefer the spoon because it does coddle your projectile. Now, we're going to see tension as I press down on the spoon. You see how it bounces? That is an example of tension. It also shows us potential energy. With the potential energy and the force that I give the spoon, I can convert that into kinetic energy. Now I'm going to press on the spoon and let our projectile, in this case the peanut, go. There we saw the potential energy convert into kinetic energy. I'm going to do it one more time. Here we have the peanut. It's placed in the spoon. Right now, that is potential energy. It's not going anywhere. It's not doing anything until I exert force on it. Right now I'm exerting force, but until I let go, we will not see that force transformed into kinetic energy. Now I will let go. And that was then formed into kinetic energy. Let's go over some words. We had tension. I mentioned that at the very beginning. The tension we can see. It's the up and down movement. Tension is created because we have these rubber bands. So it's created in the rubber bands. It builds up the potential energy and force we need for movement. And let's see it one more time. Okay, different catapults will launch projectiles in different distances depending on how much potential energy you can build up. Other factors can be the mass or the weight. So here I'm using a peanut. A peanut would travel much farther than, let's say, a cotton ball or a marshmallow because it has more weight. The projectiles, of course, show the aerodynamics of your object. Once in the air, it's the force of the gravity and the resistance that slows down the projectile, causing it to arc and eventually land. This is how we make our catapult. Be creative, have fun with it. You could even use different objects. Here I have a Lego design of a catapult. I'm using a peanut, and we see that peanut being launched. Have fun.